right, so for our main presentation tonight is well-known first here in astronomy, local astronomy, Spizzirri. We did a lot of talks locally, and I just learned he's a retired mainframe computer software engineer. I didn't know that. They call that heavy iron.
I didn't.
Well, Bill's been doing this for over 65 years. He loves doing costs. He's got tons and tons of interesting costs. He helps out on our astronomy on wheel. And tonight he will be giving us a presentation on the nature of time, which is the topic that I find interesting. So I am very interested and eager to hear Bill talk on that. This is a new topic.
Okay, thank you. Thank you, Jeff. Okay. I assume I'm being heard here and on Zoom. Is that accurate?
Yes, it is.
Okay, very good. And I have my pointer and my presentation. Okay. Yeah, time. All right. First of all, as was mentioned, I've given a lot of presentations here, other astronomy clubs, geez, even a planetarium in schools and Boy Scouts, Girl Scouts, a lot of presentations. And when I do a presentation, what I do is I pick a topic, and I hope that doesn't make anybody dizzy. I found out it was giving me a trouble at home. I pick a topic, I find out what the science says about that topic, and then I put together a presentation, okay? Well, tonight it's going to be a little different. This presentation is mostly my ideas. Oh, they're still staying. I thought they might start walking out. Okay. When my high school English teacher, Miss Vish, told me the way you give an oral presentation is you lay out all your supporting information, and then at the end you provide the conclusion from all that supporting information. And with the sincere apology to Ms. Vish, I'm not going to do that. I'm going to do just the opposite. I'm going to tell you the conclusion first, okay? Oh, by the way, this is something I've been thinking about for a long time. 1980s. I wrote a big paper on it. I can't recite the whole paper to you. We'll be here way too late. And so I'm very happy to be able to give this presentation because I want to get your comments on it. Please don't worry about hurting my feelings or getting me in trouble with me or anything like that. I really want to get your, as a matter of fact, if you give me any significant comments, help, suggestions, changes, I have an award for you. For only one person though. I can only give away one, but a scientific related thing. It's kind of nice. But anyway, so let me know what you think. All right. Okay, so what is time? So I just hit this, huh? And I did that wrong. And maybe it's not on. Let's see. Oh, it did. Okay, what is time? St. Augustine, 1600 years ago, if you're familiar with him, said, what then is time? If no one asks me, I know what it is. If I wish to explain it to them, I do not know what it is. All right. These young ladies here, I clearly they know what it is exactly. Okay. But most of us have trouble, as St. Augustine did, saying, what is time? All right. So let's see. I can't see what the next screen is going to be. And where should I point it when I do that? Should I point it at a particular place? Here. Okay, you can see the time-related joke here. It's not an easy question. You should have warned you. Einstein doesn't consider where does the time go to be a rhetorical question. He's the kind of guy who got into that issue, and just tell you when. Okay, next slide. All right. So what I did to try to figure. Okay, here's how it all started. In the 1980s, I said to myself, I want to figure out if time travel is possible. And so I thought about it for a very short period of time, and I said, I have no hope of figuring out if time travel is possible until I figure out what time is. Okay. And so I started to read a lot and listen to presentations and TV shows and go to colleges and museums and listening to presentations. Look at all, I read all this stuff, okay? And believe me, that's not everything. For many years, from, anyway, magazine, books, presentations, everything. Okay, next slide. So, what is time? It seems so familiar. We know what early and late is. We are comfortable, completely comfortable with time. We know what, oops, early and late is, past, present, future, then and now, a minute, a month, a year. We know that time can stand still or slip away. We can save time, we can lose time, we can spend time, or we can waste it, and it heals all wounds. We know everything about it. But if you ask yourself or ask me, what is it? But then all of a sudden it's trouble, okay? It's with us from our first spank to our last heartbeat. We're always working on it. But what is it exactly? Why does it pass? Okay. What does it mean to measure it? Okay. Why does it exist? Does it exist? And if it does not exist, how can we be so familiar with it? It seems like a paradox. Okay. You think this works now? Hallelujah. Okay. We saw that. I'm going backwards. Oh, I should go down. I'll get the hang of this. So what is exactly, according to me, okay, the short answer, time does not exist, but events do occur. That's the super short answer, that conclusion that my English teacher told me I'm supposed to tell you at the end, okay? Events occur. A slightly longer answer is, we only perceive the passage of time if events occur. Events are changes in matter and energy, any change in matter and energy. If events occur, we perceive time. If there are no events occurring, there is no time. Events don't seem to need time to occur, all right? The events are real. I will say time is an illusion, and we'll describe it. I'm not just going to tell you that and leave, okay? Time does not exist independently in nature. There is no substance called time that is flowing, which we commonly refer to time as flowing, you know, but I will insist there ain't no such thing. Okay. So the much longer answer as to what a time, let's talk about events. Someone once said, I thought this was brilliant, time is just one damn thing after another. And I went, holy mackerel, that's actually what I'm saying. It sounds funny, but I think that he pretty much nailed it. We see matter changes in matter. That is, we see events all around us, even inside us constantly. And when I'm talking about events, I'm talking, if I don't say it here, yeah, subatomic particle interaction, planetary motions, the flap of a butterfly wing, a single lunar orbit, the motion of a glacier, any matter, energy, change of any kind can be called, I think it's reasonable to call it an event. All right, there's all kinds of events, right? All right, I mentioned the click of a clock, excuse me, I didn't get a nap today. The tick of a clock mechanism. These are all examples of time creating events, events that, quote, create time for us, all right? The question, what is it? When you say what is time, I think it can be alternatively stated as what events have occurred, and then you know what time it is, okay? And there we go. All right, I know this is weird. Here's something that might help explain it. The big empty space on the right over there, okay? Imagine a big empty space, a very large area of space that is completely empty, with no matter in it, no energy in it. Now, there's physicists who say that you can't have that, fine, but just like John Lennon said, just imagine there's no possessions, okay? Just imagine that there is a space like that with absolutely nothing in it. I would insist there could be no time of any kind in that space if there's no matter, because if there's no matter, you can't have any changes. You can't have any events. There can never be any change there. And so that space would be totally static, unchanging, no time. Without matter, there could not be any events occurring. Time would literally have no meaning in that space. There'd be no way to perceive or measure time in that space because there's no events happening. All right. Okay. I'm saying this to try to understand the weirdness that I'm talking about here. All right. All right. The joke says there, I got to put these jokes in. I've had them in since the 1980s. I've had them in my file. I wonder what time is it in Italy? Probably half pasta something. I find a time joke. Can you go through a day without knowing what time it is? It's virtually impossible. Okay. We are all closet chronoholics. Okay. We got to know what time is. We got to pay attention to time all the time. So if you ask what hour is it, right? You're asking about time. It can be answered with a number. When that number is divided by 24, it expresses a percentage of the Earth's rotation. That's an event, by the way. Okay, that has occurred since our location was last opposite the sun. In other words, since it was last midnight here. So in other words, if you say what hour is it, and the answer is 6, 24 hours divided by 25, one Earth rotation, it's 6 a.m. So when you ask what time it is, you're really asking what events have occurred in terms of the Earth's rotation. That's really, that tells you what time it is. That's the definition of time, really, in our everyday life. So that 6 hours is 25% of an Earth's rotation, an event. All right. The question and the answer deal exclusively with the counts and order of events. Nothing else. You want to know what time it is? Just talk about events, and then you'll know what time it is. When you ask what hour is it, you don't do a calculation about the Earth's rotation. All right, we don't do that. You automatically know that when the answer is 7, when your train leaves, and when the answer is 8, work starts. In other words, all that matters is what events have occurred and what events will occur soon and in what order. That's all for everyday life. That's all you really need to know about time. What events have occurred and what events are going to occur. Then you know all you need to know about time for your day. Experience tells us all these answers, right? Experience has taught us the details of the sequence of events we perceive as time. There's nothing that we perceive as time that is flowing. All we perceive is the events, all right? Okay, so what about the beginning or the end of time? What happened before the beginning of time? Well, that's the Big Bang, and there's no events, so there is no time before events started to occur. There's nothing that we could call time that before the events started to occur. The Big Bang, according to cosmology, and that's when the first events occurred, so that's when time started. Big Bang is when time started, as far as our cosmology and physics can explain. Right? When will time end? When events stop occurring, I would say. Okay. When the universe stops changing, when there are no more changes at all, ever, of any kind. Now, that's hard to imagine unless all of space is empty or frozen, nothing moves, nothing changes, which is kind of a strange thing to think about. Until then, we will continue to perceive time. All right, wait a minute. How much time do I have? I'm sorry, stupid joke. It was a rhetorical question. Okay, what about clocks? Everybody knows, what do clocks do? They measure time. I would say don't be so sure about it. By the way, it's hard to measure something that doesn't exist. But do they measure time? Don't be so sure. All clocks, no matter what type they are, have moving parts. Somebody told me, oh, Bill, you're wrong. I know a clock doesn't have moving part. So what's that? He said a sundial. I said, oh, yeah? It's got to be on a planet that's rotating. Thank you very much. So even a sundial has a moving part. And every clock does one thing. They don't measure time. They generate equal events. The tick of a clock. I don't care what kind of clock you're talking about. A pendulum clock, an atomic clock. It's all they do is they generate equal events. All right. And then, of course, if they're a nice clock, they have a display that tells you how many events they've recorded. Okay. And so you can compare that count to other events around us, and you'll know if you're early, late, or on time, as we call it. Okay. Again, the events are real. The events created by the clock. The time we perceive is an illusion in this thing over here. No moving parts. Okay. Pendulum clocks, atomic clocks, they're all the same in that respect. And the first clocks was the solar system, planetary motion, the rotation of the Earth, the movement of the moon around the Earth, the movement of the Earth around the sun. These were our events that were generated by nature for us, conveniently. They were very dependable, and we could count to them like a clock does. They were visible to everyone, and the Earth's rotation, the revolution, the moon, these are all relatively equal events. Certainly enough for the last 10,000 years, they were equal enough. Okay, and that was our first perception of time. We saw these equal events being generated for us in the sky. We perceived time. And then we decided to use the Babylonian base 60 numbering system of 300 degrees in a circle. I didn't know that came from Babylon. I just learned that recently. And there's our seconds and minutes. Okay, so the solar system does this for us. We steal from the Babylonians, and that's how we perceive and measure time. So what's a second? If any of this is true, if any of it is true, what's a second? Well, in an atomic clock, it's exactly 9,192,000,000, what is it? I got that right, 9,192,630,000,000, whatever that number is. It's a really big number of cycles, vibrations of a cesium atom. Actually, the cycle is when an electron jumps between the two energy levels as in a cesium atom, which happens very frequently and very regularly. Okay, and that's how an atomic clock is a super accurate timepiece. And when they jump from one orbit, when the electron jumps from one orbit to another, it emits a microwave photon, and it's very easy to detect and to measure. And that's why they use cesium. And I think they use another element too, rubidium, I think, in atomic clocks. By the way, you can go to the U.S. Naval Observatory in Washington, D.C. if you haven't had the pleasure, not doing anything tomorrow. And they've got atomic clocks right there that you can go see. And they, there's no pendulums or anything. There's not much. It's a box, so it's got a gauge on it. Not really exciting, I guess. And it was agreed that these super accurate atomic clocks would be our most accurate timepiece in 1967. And I just put it there to compare it to the absolutely beautiful clocks that you see on the European churches, and they look a lot better, but they're not as accurate as the cesium. Okay, so let's see. I'm pushing the button here. Come on, button. Here we go. All right. So, so if that's the case, what's the past, the present, and the future? Something we deal with all the time. We're very familiar with past, present, and future. Well, the past, according to what I'm saying, is just a list of events that have occurred. Right? What's the future? A list of events that have not occurred yet. It's my definition. And the present is an arbitrary line we draw between those two lists. Okay? And we got our past, present, and future without any flowing time, just events. Okay? So the word now has many meanings. Now is kind of like present, the now. The word now has many meanings. A lion tamer may ask, should I let go of the rope now? That has one meaning for him. Okay. Or you might say there's a Democrat in the office now. The word is kind of the same, but there's many different meanings to the word now. Okay. All right. And of course, there's the genius of what is it over here? Yogi Berra, there's no stopping the future. And clearly the future is still to come. That was another genius who said that. Anyway, so they know a lot more about time than I do, apparently. And so, hey, what about the simple math? The classical mathematical definition of time is as follows. Speed is distance divided by time. So, for instance, 10 miles per hour, okay, distance over time, there's your speed. And so time is therefore, that's very mathematical, therefore, time is equal to distance divided by speed. And so the speed implies motion, which are events, okay? So the classical definition of time uses events in the calculation. Time equals the number of motion events that can be occurred at that speed in that much distance. Time is an event count. All right. Here's the arrow time is something that all these books and articles I've read, they just argue about it. You get an article that says, we're going to talk about the nature of time and the arrow time. And at the end of the article, they have said nothing. Okay. Futurist society, knock after entry, time joke. People have stressed about the arrow of time for centuries. The idea assumes time is an independent entity that's flowing. Okay. The big question is, why does it seem to flow in one direction from the past to the future? People argue about that. There's fights out in parking lots, outside bars, all the time about the arrow of time. It's pitiful. So here's what I have to say about that. And again, I've read a whole bunch of people talking about it. I haven't heard one good piece of information from any of these people. So I will tell you, this is my opinion here. An observer can't confirm that an event has occurred until the light from that event reaches the observer. That's kind of like a relativistic thing, okay? Light only travels in one direction away from the event and toward the observer for a given event and a given observer, okay? Once the light packet, the photons, the particles of light, move from the event to the observer, their speed and order cannot change. The order in which they leave the event is the same order in which they will be seen by the observer. Those light packets can't change order on the way to the observer, okay? Because this order is constant and unchanging, what we perceive as the arrow of time will always be forward, okay? The light from events can only occur in one direction. It's merely an artifact of the movement of light from an event, and we can't change that. This is how I perceive the arrow of time. Again, I have an award over here.
It gets complicated. I mean, with relativity, it says that anything that's outside your light cone, right?
Light cone.
There is a reference frame where you're now and that event are at the same time. So if you ask, like, what's happening in the Andromeda galaxy right now, there's a lot.
Now doesn't matter.
There's a frame of reference that says, okay, what's happening there now is what's coincident with yours, but you can also say what was happening a million years ago, and there's a frame of reference that says, no, that's now in Andromeda for you.
Right.
And there's a frame of a million years from now, because the light hasn't had time to get there from a million years ago or a million years
And you've got to wait for it to get there.
And until it gets there, any of those can be coincident with you, depending on.
And that's why there's all the fights in the parking lots, doggone it, because nobody can agree on the now, okay? All right, okay, so that's what I can say about the arrow of time. Believe me, you can read an awful lot about this, all right? So, speaking of relativity, Mr. Ed McMahon, thank you very much. Oh boy, nobody remembers who that is. Anyway, special relativity states how time is affected by speed. Ooh, how can time be effective if it doesn't exist? All right. So, time shows how time is affected as speed increases to a significant percentage of the speed of light. By the way, I think I'll talk about it later. This has been confirmed with experiments. So absolutely. I'm not trying to go say Einstein was wrong. I'll straighten him out. Okay. No, I'm not saying that. Do you have a question?
Well, no, I'm just thinking about how GPS satellites, their clock on GPS, it's slowed because of the.
It has to take relativity into account to be accurate.
Yeah.
If you're off by a little bit, then you drive into the water.
Yeah.
Yeah, right. However, I ain't no relativity expert. I've read about it, oh my God, since the 60s. I had an older brother who was really smart, and he taught me all this stuff. And I know a little bit about it, but I ain't no expert on it, okay? However, in all the equations that I've seen, and I don't necessarily understand them all, but in all of them that I've seen, whenever they talk about time, when they're talking about relativity, it's expressed in the relative operation of one clock as compared to another. And we've already talked about what the clocks do. Events, okay? The clocks may be mechanical, atomic, a pulse of light, and this has been successfully confirmed with experiments many times. So I'm not saying relativity is inaccurate in any way, shape, or form. I'm just saying whenever they talk about time dilation, the changes of time due to speed, it's clocks. All right, and I think got to take that into consideration. Let's see. However, we have already seen clocks are nothing more than equal event generators, so they are in fact affected by the speed that we're traveling at. I'm certain of that. Exactly the way special relativity predicts, but time itself is not. Clocks are affected, absolutely. As a matter of fact, I don't know if I say it here. They put atomic clocks on jet planes. They flew them to the east for I don't know how long, hours, and then they turned around and they flew them to the west. They did this in the 70s. Maybe they've done it again. I don't know. They flew them west, and these things and they changed. When compared to the clocks that stayed on the ground, they were affected by the speed of just a jet plane, let alone a relativistic speed. And of course, east and west were different. They didn't say, but I think it's because, well, the Earth is spinning at 1,000 miles an hour, going around the sun at 67,000 miles an hour. So east and west, you're going to get a few nanoseconds different in your results. But the speed affected the rate of the clocks, period. Okay? Say?
I think it's called frame gravity.
I've heard the term. I must admit, I never did quite understand it. It's beyond my pay grade, maybe. But yes, it has to do with the motion, right, through space.
Yeah, I heard it expressed one time, the faster you move in space, the slower you move in time.
According to your clock.
One way to express the relativity is just say you always move at the speed of light, but in what direction? If you use all of it to move in space, then you're not moving in time. So a photon experiences no time. If you're stationary, then you're using all of your speed of light motion to move in time.
Who understood that? Not me. I do. Thank you. I am certain you're right. I am certain you're right.
We all always move at the speed of light. The question is, in what direction in space-time do we move at the speed
I
of light?
recently hurt my foot. I'm no longer moving at the speed of light. I ripped my Achilles tendon.
Ow.
And before you ask, no, I don't recommend it. Okay? Don't do it. I'm not saying relativity is inaccurate. Your clocks are going to change if you start moving fast. If you go out on I-10 tonight, your clocks are going to get changed, okay? Because it's really very fast on I-10. And the equations make it painfully obvious. You can just see it all right here. You can see it right there. Okay. So this is how it all started with time travel. Are we then yet? Are we then yet? So, God, it's an old joke, but thanks for laughing. This is an idea that started my time quest. Okay. And there is no shortage of stories on this subject. They're all fiction. Any argument? No. Okay. So, however, if you want to travel in the past, all you need to do is a telescope. You get yourself a nice C11, okay? And you look far out into space, right? If you look further away, you're looking back in time, simply because due to the finite speed of light. However, you can see the past, but you can't interact with it, right? Okay. You can see a supernova from centuries ago, but you can't use that you're looking in the past to make a killing in the stock market. It's just the way when you look with a telescope, you see in the past, right? So this may not be a satisfying form of time travel for you, all right? Now, there is an additional bad news about traveling in the past. Astrophysicist, the late Stephen Hawking, said unequivocally, I remember him saying this, that yes, I've heard him talk when he could still talk, that you can't travel back in time, like is often done in stories, for the following reason. He said, if you were to do so, there's a possibility you could meet yourself, right? And then there would be two of you, where before there was only one of you. And he stated very simply, that means that your time travel created more matter, created another one of you. And thermodynamics, the laws of thermodynamics, it reminds us of the first law of thermodynamics, which would prevent that. We just can't create more matter in the universe. You can change the form of matter and energy and all that, but you can't just create multiple people. You know, by the way, there was a great science fiction story about this once. I forget the name. It was a terrific story. Assuming that the first law of thermodynamics is still found to be valid, then we can't go back in time. And that was his very, very short answer. Okay. I didn't argue with him, you know. What am I gonna do? I'm not gonna argue with Stephen Hawking. Anyway. Oh, and here's a perfect example of going in the past. The dog says, can we ever go back in time? Will time travel be possible? And he says, well, going back in time, that is, show me. It is now, the boy says. Right this way, sir, to a real honest to goodness time machine. He shows him a telescope. Okay, fine. We all know how that works. Absolutely. Okay, what about traveling to the future? I got to step back here. When it comes to the future, there's better news. As we already discussed, Einstein's special theory of relativity states that if you travel fast enough, you can travel into the future. The concept is called time dilation. Every relativity book will tell you about that. The faster you move through space, the more slowly you move through time. This sounds familiar. Did you just say that? Your clock mechanism will run slower, as will the biological processes in your body. The events in your body will change by the speed exactly the way the clock mechanism does. So you will age slower than those that you left behind. You will have effectively moved forward in time. You must travel a significant speed of light to do that, and we currently don't have technology to do that without killing you, to do it safely. We are, however, able to see this with subatomic particles and accelerators, such as the Fermilab in the US and CERN in Europe. We can actually see the, quote, the events of subatomic motion change when we get them going really fast around those accelerators, right? Also, while astronauts orbit Earth, for instance, on the International Space Station, they do age slower because of their orbital speed, which is approximately 17,000 miles an hour. They do, in fact, age slower, extremely small amount, okay? Because of the general theory of relativity, they also age quicker because of their distance out of the gravitational field of Earth. However, that effect is much less than their slower aging due to their speed. So we can see these effects happening because of both special and general relativity. Oh, and I mentioned this before. In 1971, they put the atomic clocks on jet planes, flew them east and west. Let's see, the clocks lost 59 nanoseconds going east and 273 going west. And they've done it a few more times, and it always works out that way. So you can go in the future. It's not easy. Don't have the technology yet, but the theory is there. Now, I know what you're sitting there going, what the heck does Bill know? What does Bill know? He doesn't know what he's talking about. And I might not. And again, if you can show me what's wrong with this, I have a prize for you, which I'll explain in a little while. In my research on this topic, I came across a satisfying corroborating opinion in the book, The Meaning of Relativity by Albert Einstein. He published in 1922. On page 30, Einstein states, upon giving up the hypothesis of an absolute character of time, it is neither the point in space nor the instant in time at which something happens that has physical reality, but only the event itself. Now, it was in English. I learned how to read fairly well. So when I see that he says that the time has no physical reality, the instant of time has no physical reality, but only the event has physical reality, I said, oh, hey, this guy sounds pretty smart all of a sudden. He sounds like maybe he's agreeing with me. And in the upper right-hand corner, you can see I was actually working with him for a while. No, do the math. I can't. That's Tussaud's Wax Museum in London. Okay, me and Einstein work. I'm straightening him out on his equations. Okay, I'm glad I got that picture. But anyway, so it seemed, according to his book, you can read it, page 30, that he seemed to be saying the same thing is. So I said here, I was glad to see that Einstein agreed that time is event dependent, even though apparently I hadn't thought of it first. I like to think of us as collaborating. We collaborated on this project together, and he just did his part 75 years before me. Okay, yeah, that's what was going on in my head. There's the book. You can see the cover of the book. Okay, so not that Einstein is the only scientist that agreed with me, but he did say the following. Past, present, and future are only illusions, even if stubborn ones. Present has no meaning in relativity. And I went, okay, so I felt good about hearing him say that. And I wasn't going to have this screen up here, but I figured I'm going to come up here and I'm going to say all this stuff, blah, 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 like pretending like I know what I'm talking about. Okay. And hoping that maybe somebody agrees with me. But then I figured you're going to say, well, just me and Einstein are the only ones who know this. I did all that reading that I mentioned to you earlier. Okay. Here is 1, 2, 3, 4, 5, 6 different scientists, published scientists, who seem to say the same thing that I was saying about time not existing, only events, time is illusion. Okay. And so it ain't just me. And I never published anything, so I don't get the credit for nothing. So there's other folks who are pretty much saying the same thing, but there's an awful lot that do not. The various descriptions of time that I have heard when I did all that reading and listened to presentations, ridiculous stuff, man. Comparing time to a loaf of bread, and I'm serious, all kinds of crazy stuff. So I see 6 guys who are pretty much, and all 6 of these guys, every single one of those 6 got really, really close to saying what I'm saying. But I think not a single one of them said exactly what I'm saying, but they got very close to it. Close enough where I salute them. Okay. Come on, button. Hit the right button. So time is an illusion. In my opinion, there is nothing flowing. Our familiar perception of time is caused only by our observation of physical events. I tried to describe them as well as I could. At first, it may be difficult to get used to this idea since we are so familiar with the idea of time. However, if you think about it for a while and you look carefully at all the various aspects of time you encounter, I think you will see there is always a connection with events, clocks, planetary motion, things like that. I suggest you give it some time to sink in. All right. That's what I wanted to say. Thank you very much for your time and attention. Please wake up the person next to you. I put in here. Also, again, if you have any way you can contribute to me, tell me what I'm doing right or wrong. Show me my mistakes. I make them. Okay. I have a prize here for you. And I'll tell you what the prize is to try to encourage you to talk to me about this. Several years ago, I was touring Northern Europe. I stopped in Sweden. I went to fortunate enough to go to the Nobel Prize Museum there. Big deal. You have had the pleasure? No? It has information and displays about every Nobel Prize that's ever been given, documents, videos, hardware from experiments. It's a wonderful place. And so I said, oh man, this is great. I need to get a souvenir from this place. So you know what I like? I like to just get a little phony plastic Nobel Prize just to hang on the wall, you know. I figured that'd be a common souvenir to get from a museum like that. I go up to the counter, I don't see one. I go up to the counter, I ask her for it. She goes, oh, no. We cannot have those because then there'll be people going around, oh, look, I got a Nobel Prize, blah, blah, blah. And so they absolutely positively don't do that. But as an inducement to you, and you don't have to talk about tonight, we can talk in the parking lot, we can go to a bar. I can't drink, but we can go to a bar. And what I found at the Nobel Prize Museum, these chocolates, and they're wrapped in gold that look just like a Nobel Prize. And it would be my great pleasure. And I only got one that I can give you. And by the way, you can take the chocolate out and eat it and still keep the gold thing. It's suitable for framing or not, or whatever. So I'm just trying to induce you to give me your comments. Thank you very much for your time and attention. And that's all I got to say. Oh, I'm sorry.
All right, the last slide has got to be the future license plate that says out of time.
Out of time. Well, I had the car there, if you noticed.
Yeah.
There was only so many pictures on the web. No.
Yeah.
And I guess I am now.
Out of time.
Yes, I am. Whatever that is. Does that exist? I don't know.
Uh,
Was there another question? Did I see a hand? No.
I do.
Yes, sir.
I've been talking about this and terms of eternity and like from the spiritual aspect?
Eternity,
Yes.
yes? Oh, you're asking me?
Yeah, what's your view on that?
I think I touched on it early on when I said we will always perceive time as long as there are events occurring, changes occurring of any kind in the universe. And will the universe last, quote, in eternity forever? I don't know. You're getting fights in the parking lot about that too. Okay, right? And if you know, where's your evidence? It's tricky. Okay, so that would be my answer. As long as there's changes, events occurring, even if there ain't any of us, time will still exist and we'll be moving toward eternity at the very least. Thank you. Any other questions or comments? Yes, sir.
The quote by Einstein about time being an illusion.
Yes.
The way I understand it is that was in a letter to a friend of his who had lost her husband. He was consoling her. And you won't find that in one of his books or papers.
Sounds familiar.
But, I mean, it could be prophetic.
Yeah, maybe so. You know, he pretty much nailed it. You know, he had the whole relativity thing nailed down. Yeah. Yeah, okay.
He's pretty relevant.
Thank you. Pardon me?
He's pretty relevant.
Yes, he is. Absolutely. Yes. Anything else? Thanks again. I guess I'm done. Thank you. Thank you very much.